So let's talk about interpreting unit rate as slope. We are focusing on the exact same thing, direct variation. We're focusing on the equation y equals kx. That has been our sole focus, right?
Yes.
And we're going to continue that. This is one of the most important things you can learn. By the way, you guys, thank you for being good. Last week when Miss Holloway was in here, I was getting my evaluation. You may or may not have known that, but you guys were like into the lesson. You were responding. I was like, it was awesome. I was worried that there wasn't going to be response. You guys were jumping all over it. So it was good.
Yeah, I was making sure I wouldn't get in trouble on this all the
Yeah.
Is that what it was? Good. So I need to invite her more often.
No.
So Thomas rides his bike at a steady rate of 2 miles every 10 minutes. Graph the situation, find the unit rate of this proportional relationship. And I know he's got his name spelled wrong. Stupid spell check. It was supposed to be Tomas. No mas. But let's talk about the unit rate. Now, they gave it to you here, right? When you think about a unit rate, we're talking miles per minute, right? Do you guys agree?
Yes.
And what we're really honestly looking when we do unit rates, we want something equal to 1. That makes life easier. So 3 miles every minute, which would be fast if you're running.
Yeah.
3 miles to the minute.
That would be C.
Oh my gosh, that's fast.
So
Is that even possible?
No.
No.
So let's go up here and figure out what's going on. How many miles? 2 miles, and how many minutes? So we've got 2/10. What can we change that to?
1/5.
So he runs 1 mile every 5 minutes. Does that make sense?
Yes.
So what's the unit rate?
1/5.
1/5 mile per minute.
That's really fast.
How would we?
But he's riding a bike. He's not running. It's just funnier to say he's running.
Can you actually like go that fast in something?
What? 5 miles and or no? A minute. And
You could do that on a bike easy.
What? 2 miles in 10 minutes?
No, 1/5 of a
Yeah,
mile.
but you get me running.
Yeah,
His
2 miles,
takes
10
a little
minutes.
longer than
I can
that.
do that running.
Well, you're impressive.
Okay, let's go
I
see
couldn't.
Jack,
I can
All right,
run that.
so now let's graph it. Honestly, shh. I tend to like big numbers. Now we know in direct variation, 0, 0 is always one of our points, right?
Yeah.
So we own one. We just need another one. I like to go way out to the tens or something to the right side of it. So when I get my number, I get a good straight long line. There's a lot of you doing dot 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 dot, and you have this like curved line that looks like a pot of peas. So 10 miles. How far did he go?
2 miles.
2 miles.
El Chuo Mayo.
He went 2 miles.
Just all.
Oh, 10 minutes.
10 minutes. He went 2 miles, right?
You put on 5.
I'm sorry. That was me touching where I wasn't supposed to. Then all you got to do is connect the line.
Hey now. Hey.
Do not make a wiggly squiggly line.
I want to make a wiggly squiggly line.
Some of you did make a wiggly squiggly line.
I like a wiggly squiggly line.
I noticed that.
Okay.
Isn't that really?
Yeah, that's my rule.
What is that noise?
Use
It's my phone.
Reagan, can you get me one?
Right away. You gotta go say hey, sexy.
I need one.
What's sexy to me?
It's hey good looking.
Yeah, it's hey good looking.
Give me one.
Okay,
Oh my god.
come on, you guys. You're taking time again.
Grab 3. Hey, grab 3.
This is a Christian school, John. We don't take our name.
Hey, you guys all have a straight edge. Those boards are all straight edges.
I know, but I don't like
Okay, so now I've graphed it. I have basically or not interpreted. I've interpreted
I like that one.
the statement and made an equation and a line. So we could write that line on forever. So we can figure out if we tell Thomas don't come back until this many hours have passed, we can run that line out and see how far we expect him to be.
Whoa.
Who's Thomas?
I don't know. It's this guy. It's just random
Did you
ink.
write this?
Some of it. Some I write, some I borrow.
The move.
But you don't give credit to them, so you copyright.
I do give credit.
How?
You have to ask that later. All right, so let's look at the next one. We've got an equation here, and it says the equation y equals 375x represents the relation in x, the time that a plane flies in hours. So that's x, right? and y, the distance of plane phi in miles. So this is for plane A, right?
Yes.
Okay, so that's plane A. Now, when y equals 375x, what does 375 equal in variable names? What's the only equation we know so far?
Y minus KX.
So what does 375 represent? K, the constant of variation. So we've got plane A, and it's y equals 375x. So we don't have to do any work on that one. It says plane B is this table here.
I don't like playing B.
Well, how do I get K? Remember, if y equals kx, you guys buy that? If I do some strange math or normal math, how do I get k off this side? Actually, how do I get x off this side?
Add it to the other side.
K and x are divided or multiplied, right?
Yeah.
If I divide this side by x, what's that going to do to these two? They're going to,
Cancel them out.
but I got to do it both sides. So k actually equals y over x, doesn't it? Well, let's look at here. It says we've got time. Time we say is x. Distance is y. The tables are always written as xy. Unless they're evil people.
Which they're never.
So let's find, all we need to do is find, they've already told us it's proportional. So all we need to do is find 1y over 1x. Which one do you want to use? We can use any of them, but which one would you prefer to use?
The small one.
Why?
Because it's easier.
Let's use this one. So it says y over x, right? Well, what's the number? What's y?
Wait, why is it Y over X if it says X over Y?
So,
It never says x over y.
You just
Oh, that's a table. But that's not our equation. Tables are always written this way, but the equations are... Sit up, Del. Sit up. Thank you. So, what's y in this one? 425 over 1. What's anything over 1? So what's the equation for this plane here, for plane B? Y equals what?
425.
Y equals 425x. Well, now it says find the slope of the graph for each plane and the plane's rate of speed. Determine which plane is flying faster. Well, the slope of the graph is a fancy way to say what's the slope of the line. Because a graph is just a line in the equation, right? So what's the slope of this first one up here?
375.
375. What's the slope of this plane? Which plane is going faster?
A.
B. It's going 425 miles per hour. A is only going 375 miles per hour. Which is why I don't like... Huh? This is all we're doing. Any questions on this?
Homework. Bye.
Bye.